Hello everyone, myself Vinay Kumar. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I had started the exercise questions of exercise 9.3, which were there in circles chapter, that is the 9th chapter in 9th standard mathematics. So in that particular video, I had solved the first four questions of exercise 9.3. So the remaining questions which were remaining in that particular exercise 9.3, I'll be discussing in this video and in the next video as well. So now we will move to the next question which is there in this particular exercise 9.3. So the next question is fifth question. So solutions for first to fourth question will be in my previous video. So if you want to know the solutions for them, then please refer my previous video. So now we will look into the fifth question. So here in fifth question, they have given a diagram. So let me draw that particular diagram over here. So there is a circle like this, and in this particular circle, they have given a card. So there is a card like this. So this card is named as BC. And there is a point A at this particular position. And there is a point D at this particular position. Now, AB is connected and AC is also connected like this. So now, this particular card BC also subtends an angle at D. So BD is connected and CD is also connected like this. So here they have given this particular angle as 130 degree. So if this particular angle is 130 degree and if this particular angle is 20 degree, then you have to prove the angle BAC. So that is, you have to prove this particular angle BAC. So now we know that BD is a straight line. So here BD is a straight line. So here BD is a straight line. So therefore B and this particular intersection point, that is AC and BD intersection point, is named as E. So here therefore BEC angle plus CED angle, that is this particular 130 degree and this particular angle, if you add, they should be equal to 180 degree. So is equal to 180 degree because BD is a straight line. So they form a linear pair. So they form a linear pair. So now here already BEC angle they have given, that is 130 degree. So 130 degree plus CED is equal to 180 degree. So now 130 degree, if you bring to RHS, it will become 180 degree minus 130 degree. So CED is equal to 180 degree minus 130 degree, which will give you 50 degree. So that means here CED is 50 degree. So if CED is 50 degree, then you can consider this DEC triangle, and sum of interior angles of triangle is equal to 180 degree. So 50 plus 20, and if you add this particular triangle, this particular angle in the triangle, then that should be equal to 180 degree. So now consider, so this is therefore CED is equal to 50 degree. So now consider triangle DEC. So here DEC angle, or you can write this as CED also. So CED angle plus EDC angle plus DCE angle is equal to 180 degree. So what is CED? CED we have got as 50 degree plus EDC we don't know, plus DCE, that is 20 degree. So here they have given 20 degree. So which is equal to 180 degree. So 50 plus 20 will be 70, and 70 if you bring to RHS, it will become minus 70. So EDC is equal to 180 degree minus 70 degree. So this will be equal to 110 degree. So now here we have got this particular angle as 110 degree. Then this angle will also be 110 degree because BC acts as the arc. So if you consider BC as arc, so you can consider the major arc BC, and this particular BC arc is subtending an angle at A, and the same arc is subtending an angle at D in the same segment. So that means the angle subtended at A and the angle subtended at D by the same major arc BC will be equal to each other. So therefore EDC angle is equal to BAC angle, which is equal to 110 degree. So here EDC is 110 degree. So EDC, I can write this EDC as BDC as well. So EDC is equal to BDC is equal to BAC is equal to 110 degree. So now we'll move into sixth question. So in sixth question, they have not given the diagram. So we have to construct the diagram. So here in sixth question, there is a cyclic quadrilateral. So in which this particular point is named as A. So this particular point is named as A, B, C, and we have D. So let's assume A, B, C, D as a cyclic quadrilateral, where all the four vertices of this particular quadrilateral lie on the circumference of the circle, somewhat like this. So now approximately I am writing this particular diagram. So here the data was what they have given is AB is equal to BC. And one more data they have given here, A and C are connected like this. So here A and C are connected like this, and they have given the angle BAC. So this angle BAC is 30 degree, and they have given the angle DBC also. So the angle DBC is equal to 70 degree. So based on this data, they are asking you to find out ECD angle. So E is the point of intersection. So this particular point of intersection you can consider as E, and ECD angle you have to find out. So this particular ECD angle you have to find out, and you have to find out BCD angle as well. So that is the total angle BCD also you have to find out like this, and the angle ECD, this particular smaller angle, this also you have to find out. So in order to find out this, the data what they have given is ABCD is a cyclic quadrilateral and AB is equal to BC. So let's take this point as the center point of circle O, just to name this circle. So consider the circle O. Consider the circle O in which it contains, in which ABCD is a cyclic quadrilateral. So ABCD is a cyclic quadrilateral. So in this cyclic quadrilateral, we have AB is equal to BC, and AC and DB are the diagonals. So AC and DB are diagonals, and the data what they have given here is, so the data which they have given here is DBC angle they have given. So DBC angle is equal to 70 degree, and they have given BAC angle as 30 degree. So now based on this, you have to find out the total angle BCD and the angle ECD as well. So now in cyclic quadrilateral, if you add the opposite angles in cyclic quadrilateral, then the sum will be equal to 180 degree. So that means here BAD and BCD if you are adding, then that will be equal to 180 degree. But before that, we don't know what is the total angle BAD. We only know this particular BAC angle, that is 30 degree. We don't know what is this particular angle. So in order to find out this particular angle, we will consider this angle, that is DBC. So here you can see DC acts as the arc. So here DC is an arc, and this DC is subtending an angle at point A, and DC is also subtending an angle at B. So that means here this angle will also be equal to 70 degree. So here DC is an arc. So here DC is an arc. Consider minor arc DC. So consider minor arc DC where DC is subtending angles at point A and at point B. So therefore here DAC angle is equal to DBC angle, and we know what is DBC angle. So DBC angle is 70 degree. So therefore the total angle BAD, so the total angle BAD so is equal to DAC plus BAC. So here we have proved DAC is equal to DBC, that is equal to 70 degree. So DAC is 70 degree and BAC they have given as 30 degree. So therefore BAD angle is equal to 100 degree. So we know that BAD angle plus BCD angle, so that is the opposite angles of this particular cyclic quadrilateral. If you add them, that will be equal to 180 degree. This is according to theorem 9.10. So this we have seen in my previous videos. So now BAD is 100 degree. So we have proved BAD as 100 degree. So we don't know what is BCD. So BCD is equal 100 degree plus BCD is equal to 180 degree. So therefore BCD is equal to 180 degree minus 100 degree, which will be equal to 80 degree. So now we have got BCD as 80 degree. Now we have to find out ECD angle as well. So in order to prove what is ECD, we'll consider this particular triangle which is there like this. So in this triangle, we have ABC like this. So we have an ABC triangle like this. So this is A, this is B, and this is C. And the data what they have given is AB is equal to BC. So this acts as an isosceles triangle. So in isosceles triangle, opposite angles of equal sides will be equal. So that is this particular angle will be equal to this particular angle. That is BAC will be equal to ACB. So now here we know BAC is 30 degree. So that means this particular smaller angle will also be equal to 30 degree. So the total angle we know, the total angle we have proved as 80 degree. And in that this smaller angle we know that this is 30 degree. So 80 degree minus 30 degree will be 50 degree. So now we will try to write those in statements. So consider triangle ABC. So consider triangle ABC. Here AB is equal to BC. So here AB is equal to BC. Therefore here BAC will be equal to ACB. So here BAC will be equal to ACB. So BAC is equal to ACB, which is equal to 30 degree. This is according to isosceles triangle property. This is according to isosceles triangle property. So now ACB we have got as 30 degree and BCD we know that is 80 degree. So the total angle BCD, so the total angle here, the total angle BCD is equal to ACB plus ACD. So ACB plus ACD. So that is ACB. So this particular angle ACB and this particular angle ACD. So the total angle is the sum of ACB and ACD. So now the total angle BCD we know that is equal to 80 degree. So now we are getting ACB plus ACD. So 80 degree. So one more time I'll write BCD is equal to ACB plus ACD. So here BCD we know that this is equal to 80 degree and ACB as 30 degree plus ACD. So 30 degree if you bring to LHS it will become 80 degree minus 30 degree, which is equal to ACD. So therefore ACD is equal to 50 degree. that is, if ACD is equal to 30 degree, that is ECD is also equal to 50 degree, because E lies on the AC straight line. So since E lies on the AC straight line, I can replace A with E. So here we have proved is ACD as 50 degree. So that is this particular angle as 50 degree. So that means ECD is equal to 50 degree because E lies on line A. So ECD they had asked to prove, and we have proved ECD is equal to 50 degree. And in the previous case they had asked to prove BCD also. So BCD is 80 degree, and they have asked to prove ECD also. ECD is equal to 50 degree. So now we will move into the next question, that is to the seventh question. So here, if diagonals of a cyclic quadrilateral are diameters of the circle, that is basically diagonals are getting equal to each other of a circle through the vertices of the quadrilateral, prove that it is a rectangle. So first we will try to draw a circle like this. So in this circle we have a particular cyclic quadrilateral like this. So we have a cyclic quadrilateral where diagonals are equal to each other and they are the diameter of the circle. So because both the diagonals are diameter of the same circle, they are equal to each other. So if this is the center point of the circle, then the diagonals of this quadrilateral pass through the center of this particular circle like this. So that means here ABCD we are considering as a cyclic quadrilateral. So here ABCD is cyclic quadrilateral, and let's call this as the center point O, where the diagonals are diameter of the circle as well. So that means AC is diameter, DB is also diameter, and both are diameter. So that means diagonals are already becoming equal to each other. So now you have to prove that this particular cyclic quadrilateral is a rectangle. Draw a circle with center O. Draw a cyclic quadrilateral. So draw a cyclic quadrilateral. Their diagonals pass through the center of the circle. Pass through the center of the circle O. So center of the circle O. So here AC and DB are the diagonals of this particular cyclic quadrilateral, which is passing through the center of the circle O. So that means basically diagonals are acting as the diameter of this particular circle. So now we have established the diagram. We have to prove that this particular quadrilateral is a rectangle. So in order to prove that, now we will consider AOB triangle and DOC triangle. Consider triangle AOB and triangle DOC. So now we are considering triangle AOB and DOC, that is this particular AOB triangle and DOC triangle. So here AC and DB are straight lines. So these two angles acts as vertically opposite angles. This side is equal to this side. This side is equal to this side because they are the radii of same circle. So here AO, so here AO is equal to OC and BO is equal to OD. This is because they all act as radii of same circle. So radii of same circle. So that's why AO is equal to OC, BO is equal to OD. And here AOB is equal to DOC because they act as vertically opposite angles. So here you can see in this diagram the sides are becoming equal to each other. So two sides of these two triangles are becoming equal to each other, and the angle between these two sides and the angle between these two sides in DOC and the angle between these two sides in AOB are also becoming equal to each other. So that means according to SAS, that is side angle side postulate, AOB and DOC are congruent with each other. So therefore triangle AOB is congruent with triangle DOC. This is according to SAS postulate, or can just write SAS axiom. So according to SAS axiom, these two triangles are becoming equal to each other. So these two triangles are becoming congruent with each other. So that means here AO is equal to OC. So that means this particular angle and this particular angle will be equal to each other. So therefore angle BAO, so the angle BAO will be equal to angle OCD. So angle BAO is equal to angle OCD. This is according to CPCT, that is corresponding parts of congruent triangles. They will be equal to each other. So therefore here AB is parallel to DC. This is because BAO is equal to OCD. That is here alternating angles are becoming equal to each other. So that means here AB will be parallel to DC. So now similarly we have to prove AD is parallel to BC. So in order to do that, consider triangle. So now we will consider this particular triangle AOD and BOC. So consider triangle AOD and triangle BOC. So in triangle AOD and BOC, here also AO is equal to OC and here DO is equal to OB. So here DO is equal to OB. Radii of same circle, because they all act as radii of same circle. AOD angle is also equal to BOC angle because they act as vertically opposite angles. Similarly, how I did for the previous case, here also you can do the same thing. So therefore triangle AOD is congruent with triangle BOC. This is also according to SAS axiom. So now since AOD is congruent with BOC, so this particular angle DAO will be equal to this particular angle OCB. So therefore, so DAO angle is equal to OCB angle. So therefore, this is according to CPCT. So corresponding parts of congruent triangles. So that means here alternating angles are equal to each other. So therefore, AD is parallel to BC. So this is according to DAO is equal to OCB. So that is alternating angles are equal to each other. So you can write alternating angles are equal. So alternating angles are equal. We have proved AB parallel to DC and we have proved AD parallel to BC. Opposite sides are, so that is opposite sides are parallel to each other. So opposite sides are parallel to each other. So now we have proved opposite sides are parallel to each other. Now we have to prove opposite angles are equal to 90 degree, 90 degree. So all the angles in this quadrilateral should be equal to 90 degree. So therefore we have proved that ABCD is a parallelogram. So we have proved ABCD is a parallelogram. Now we have to prove ABCD is a rectangle. DAB plus, so here DAB plus BCD. So DAB plus BCD, if you are adding together, they will be equal to 180 degree. This is according to theorem 9.10. Because in a cyclic quadrilateral, opposite angles if you are adding together, then that will be equal to 180 degree. So now we have to prove that DAB and BCD are equal to each other. So in order to prove that, consider triangle. So now we will be considering the bigger triangle like this. So now we will consider the triangle ABD and we will consider this particular triangle, that is this triangle which is BCD. So in these two triangles, this particular angle and this particular angle will be equal to each other because we have proved AOD and BOC are congruent with each other. So that means this angle and this angle will be equal to each other. And here this particular angle will be equal to this particular angle because we have proved that AOB is congruent with DOC. So that means this angle and this angle will be equal to each other. This angle and this angle will also be equal to each other. And BD acts as the common side. So according to AAS postulate, these two triangles will be congruent with each other. So that means BAD will be equal to BCD. So now we will try to prove that. So now consider triangle BAD and triangle BCD. So here you can see this particular angle DBC will be equal to BDA. So here consider triangle BAD. So BDA angle is equal to DBC angle. So BDA angle is equal to DBC angle. This is because triangle AOD is congruent with triangle BOC. So this we have proved. So now similarly these two angles will also be equal to each other. That is ABD and this particular angle BDC will also be equal to each other. So ABD angle will be equal to BDC angle. So ABD angle will be equal to BDC angle. This is because we have proved triangle AOB is congruent with triangle DOC. So triangle AOB and DOC are congruent with each other. So this angle is also equal to each other. And here BD is equal to BD. This is because they act as common side. So BD act as common side for both the triangle. Therefore, triangle BAD is congruent with triangle BCD. This is according to AAS axiom. So this is according to AAS axiom or AAS theorem. So according to angle side theorem, BAD is congruent with BCD. So therefore here DAB is equal to BCD. So therefore here DAB is equal to BCD. This is according to CPCT, that is corresponding parts of congruent triangles. And we have seen here that DAB plus BCD is equal to 180 degree according to theorem 9.10. So this you call as equation 1. This you can call as equation 2. So now we will rewrite this equation 1, that is DAB plus BCD is equal to 180 degree. So here DAB is equal to BCD. So in the place of BCD, I'll write DAB only. So DAB plus DAB is equal to 180 degree. So 2 times DAB is equal to 180 degree. So here DAB is equal to 180 degree by 2. So 180 degree by 2 is 90 degree. So that is equal to BCD. So here opposite angles are equal to 90 degree. So therefore ABCD. So here we have proved DAB is 90 degree and BCD as 90 degree. So of course the other two angles will also be equal to 90 degree only. So therefore ABCD, because in a parallelogram, if one angle is equal to 90 degree, then all the interior angles of that particular parallelogram will be equal to 90 degree. So here we have proved DAB is equal to 90 degree. So ABCD is a rectangle. So here ABCD is a rectangle. So this is what they had asked to prove, and we have proved that. So now we look into the 8th question in this exercise 9.3. So non-parallel sides of a trapezium are equal. Prove that it is cyclic. So now here let us consider the trapezium like this. So let us consider the trapezium like this. So here this trapezium will name as ABCD. So in this 8th question they have asked non-parallel sides. So here AD and BC are not parallel to each other. So these non-parallel sides are equal to each other. So that is AD will be equal to BC. And here AB is parallel to DC. So now you have to prove that ABCD trapezium is a cyclic quadrilateral. So in order to prove that, here first we'll draw perpendicular line from A onto DC, and we'll also draw perpendicular line from B onto DC. So that means this angle and this angle will be equal to 90 degree. So consider trapezium ABCD such that AB is parallel to DC and AD is equal to BC. So here draw perpendicular line. So draw perpendicular line from A on to DC and perpendicular line from B onto DC. So this point will name as the X and this point will name as Y. So AX is perpendicular to DC and BY is perpendicular to DC. So that is AX is perpendicular to DC and BY is perpendicular to DC. So since AB is parallel to DC, so since AB is parallel to DC, therefore AX will be equal to BY. So AX will be equal to BY because here we have proved AX is perpendicular, because here we have drawn AX perpendicular to DC and BY perpendicular to DC. So AB is parallel to DC. So we are taking perpendicular distance in between the parallel lines. So all those perpendicular distance will be equal to each other. So that means AX will be equal to BY. So now we will consider this particular triangle AXD and BYC. So consider triangle AXD and triangle BYC. So here, since we have taken perpendicular line, so AXD will be equal to BYC will be equal to 90 degree. This is from construction. So we have constructed this. So we can write from construction in the bracket. So here AX is equal to BY. So this is because AB is parallel to DC. Now AD is equal to BC. This already they have given in the question. So now right angle, hypotenuse and one side is getting equal to each other. So therefore triangle AXD is congruent with triangle BYC. This is according to RHS theorem. So this is according to RHS theorem. So therefore this particular angle ADX, this particular angle BCY will be equal to each other. That is, here angle D will be equal to angle C. Straight away I'll just write angle D is equal to angle C. This is according to CPCT, that is corresponding parts of congruent triangle. So D is equal to C. So now since D is equal to C and here AB is parallel to DC, this particular angle A and angle D acts as corresponding angles on the same side of traversing line. Here AD acts as traversing line between AB and DC. So AD is a traversing line for AB and DC. So AD acts as traversing line for AB and DC. So therefore here angle A plus angle D will be equal to 180 degree. So this is because AB is parallel to DC. So AB is parallel to DC. So A plus D will be equal to 180 degree. Now we know that D is also equal to C. So here we know that D is equal to C. This we have proved. So this we have proved. So therefore angle A plus angle C, or else I'll write this in new slide. So you can write this in new slide. Here we will consider A plus D is equal to 180 degree as equation 1. So here we'll take equation 1 once again. So A plus D is equal to 180 degree, or you can write this as A plus C is equal to 180 degree. So this is equals, so A plus D is equal to 180 degree. That can be written as A plus C is equal to 180 degree because D is equal to C we have proved. So here you can see sum of opposite angles of a quadrilateral is becoming equal to 180 degree. So therefore ABCD is cyclic. This is according to theorem 9.11. So this is according to theorem 9.11. So this is what they had asked to prove in this question and we have proved that. So this is all there in this particular video. The remaining questions which are there in this exercise 9.3, I'll be teaching that in my next video. Until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.